This problem is the light bulb problem, and as I understand it, I'm giving an input, and the list of integers here are the order at which I need to turn on the lights. So like first number is 2, so light number 2 turns on. Then the next light number 1 turns on. Next light 3 turns on. Next light 5 turns on. Next light 4 turns on. And I need to turn on these lights in this order. And these blue lights appear when all the previous lights before it is turned on. So for example, 2. The first light to turn on, 2. The previous light is not on, so 2 is not blue. It just stays yellow. And then the next light, 1. You turn on this light, and then instead of yellow, since there's no previous light before it, 1 always starts off blue. Never yellow, but it always starts off blue. And as for 2, it was previously on, and why it's blue is for the reason is because before 2, this light is on. I don't care whether or not it was blue or yellow, but it's blue in this case. But yeah, previous light is on, so therefore itself is a blue light. Change from yellow to blue. Then the next light, 3. So 3 turns on, but instead of yellow is because 1, 2 are also on. All previous lights before 3 is turned on, so therefore light 3 is blue instead of yellow. Then the next light 5 turns on. It stays yellow because not all the previous lights are turned on. Number 4 is off, so light 5 stays yellow. Then 4 turns on. So 4 is blue because 1, 2, 3 are on, so 4 instead of yellow, it turns blue. And as for 5, since all previous lights before 5, so instead of yellow, it changes to blue. And that's my understanding. And my output is I need to get the number of times when all turned on lights are blue. So moment 1, moment 2, that's when all the lights are all blue, all the on lights are blue. And for moment 3, this doesn't count because light 5 is yellow. So for these 4 lights that are turned on, not all are blue because 5 is yellow. And in moment 4, all the lights are blue. As soon as all lights are turned on, all lights turn to blue. So that's what my understanding is. So I already explained my understanding. So match. The match is surprisingly is the missing number in the sequence problem, and the reason why is because all previous lights, if all previous lights are turned on, that's when things are blue. So only previous lights. So in this case, it happens to be the sum, the sequence sum. So what's the summation of a sequence of n? In this case here, in moment 1, n is 2. So 1 plus 2, that's a answer is 3. Then I also take this sum of this. Well, let's say here 2 and 1. The sum of 2 plus 1 is 3, and since the series summation of up to n, in this case 2, is 3, is also equals to these first 2 numbers. The summation is also 3, so therefore all the lights are turned on. So in a sequence, the sum generally always match the light bulb number here. So 2, 1, 3, the summation is 6. here 2 plus 1 plus 3 is 6, and at summation of n equals 3 is also 6. So that's when all is blue. Here 5. So the summation of this up to this sequence is 2, 1, 3, 5, and that equals to 11. But here in this position, this is position 4, so n is equal to 4 here because this is the fourth light turned on. So summation of n equals 4 is 10. 10 does not equal to this summation of 11. So I'm just going off by the position here. And this is position 1, 2, 3, 4, and 5. So I'm just going off by position. So the summations, if the summation are equal, well then all the lights were turned blue. If not, then there was at least one light that was yellow. So it's very similar to the missing numbers sequence because I just need to add and then do a subtraction of the whatever the input list was and subtract, and that was my missing number. Here I'm actually just comparing the summations and the summation here and the sequence summation, and I just need to see if they are equal to each other, and I just need to count how many times they are equal to each other. So the plan is, well, I need to make some containers. So some of the lights in the sequence, let's start off with 0, and I need to count how many times all the lights were blue. So I'm going to need a for loop here, ranging from 0 to the length of the input list. Input list. I'll be using I. So let's see. So I'm going to find the sum. So the sum at this current iteration plus equal to the input list at I, and then I need to check while in my current position. So I need to check if it's equal to the to like n. In this case, n is index plus 1 because index starts at 0. I don't want to start at 0. The sequence always starts at 1. So, and the formula to summation is n times n plus 1 all divided by 2. So here is I plus 1 multiplied by I plus 1 plus 1 divided by 2. And I'm going to simplify these 2 plus 1s into just add 2. So that's when I need to count, that's when they're all blues. And then I just need to return that number, count all blues. And because of the math property here of summation, it makes this problem quite easy, and it's solved in O of n instead of O of n squared, which will have me going the list twice with a double for loop. But thanks to a pattern that can be seen, you don't need to do a double for loop. You just need to recognize that this is just a summation sequence, and that's all you need. Return count all blues, and you're done.